Most of the time I'm out there with the camera. Whatever standing still.
Well, I got the fragments and real fragments from the heat shield.
Oh, those are cool.
I wanted to do
There's a couple of pictures of S24 in the presentation, so we need to find out which tile it was.
Would be a bit hard.
Yeah, just a little bit. This whole thing comes apart too, so you can see all the insides. There's all the tank structures and everything.
You make this yourself?
I printed it, but I didn't make the model. There's a guy called Starship 3D that went over all the pictures of. This is SN8.
Oh.
So they went through all the pictures and documented where all the tanks are located. There's all the COPVs inside.
Yeah, great.
The bottom, I think, is the best. So we take the fins off. There's all the Raptor engines and the COPVs. Hydraulic power unit. A lot of extra support structure on the bottom. The rest of the tanks maintain strength because of pressure, like a soda can.
Yeah.
But under the engine bay, there's no extra support, so they put all the extra steel stringers on the sides.
I was like, this is like the earlier prototype.
Oh yeah, this is SN8. This was the first full-size one to fly with the flaps and everything.
It's probably about 7. Well, don't you want to see it?
I'm gonna see how many girls have their
Bing
one.
bong. And that's the methane transfer tube. And,
Yep. Methane transfer tube is here. The header tank transfer tube is along the side there. There's the oxygen header tank. There's a little ball here.
yeah, I know all about Starship.
I've been watching them build it since the original Starhopper.
Me too.
It's such a neat thing that they can do this all out in the open where everybody can see it.
Yeah. No, I hope I can visit there someday.
Yeah, it's on my list. I had a friend that worked there for a while. He kept trying to get me to come down, but I never had time.
It would also be cool if there was a model that had the tiles. But
Yeah, I could have printed the tiles for this. This one had a small, on the front there was supposed to be like a cluster of 6 or 8 of them. But I never bothered to print them because they weren't super important for this flight. But someday I need to print, I'll probably print Booster 7 and S24.
is the presentation going to talk about V2 Starship at all? Because that was announced recently.
Yeah, I'm gonna bring it up. At least I'm gonna mention it. But we don't have a lot of details other than that it's gonna be a little bit stretched, just to add more capacity for the pallet, and it'll probably use Raptor 3s.
It
Yeah.
varies year to year.
Yeah, I remember I asked a while ago. What would be the first one?
Might get some interference from the
Yeah, I think it's going to be way later because they got to get through that whole crop of Raptor 2s they came out with. They have so many of them.
late at night.
Still on flat.
Quite a bit, exactly.
Was this looking well?
Back in 2001, a year or so after there was a major storm. But there was a storm that year. And it was raining like you've never seen before in your life. We had people camped out on the football field and slept here all night just staring up to the sky.
Yeah, I found that when handling these tiles, it's best to wear gloves because they are fresh.
Shooting stars.
They are actual flight
You never know.
fragments.
Like,
Yeah, these are really cool.
you go into the room, there's the telescope if you like.
I'm kind of half expecting some remnants of Ship 25 to eventually wash up on the Florida coast or maybe along Cuba. Once the ocean currents take them wherever they want to go.
Well, I have already found some people selling like pieces of them. Maybe I can find the listing. Now, someone apparently found a whole S-25 tile.
I saw one of the COPV tanks washed up. Somebody sent a picture of that in.
Oh. Well, here's one piece someone's selling.
Oh.
Oh, jeez. Wow.
See, looks like a metal
She
section.
needs two seats.
Yeah.
Are you good to sit there?
Not sure what kind of piece that would be
Are you
from.
good to sit right there?
Maybe the booster.
Now, the booster wouldn't have made it that far.
Oh.
Anything from the booster would be in the... Well, if it's in the Gulf of Mexico, if they found it in Mexico, that probably is booster then.
Don't judge me. I'm in my
If it was in the Caribbean or on the coast of Florida or Cuba, then it's probably from the ship.
You never know how to dress. Snow in the morning, sun in the afternoon.
Here's another one.
Found a Starbase Boca Chica.
There were some tiles that did fall off earlier. That's probably from one.
Yeah, those would have likely fallen closer to the launch site. That might have been from like SM-10 or one of the earlier ones that, or 11. 11's one that blew up in the atmosphere.
Yeah. Yeah, but you want to like touch these. I do have a pair of gloves. You have to
Yeah.
be very careful.
Take a close look at them after the presentation.
Okay. Yeah, I was thinking we could put them on like display and.
Yeah, we have the display case in there. That'd be a perfect place for them.
Oh, you do have a place for them?
Yeah. We have a nice glass display case with the shuttle heat tiles.
Mm.
And we have a little model of New Horizons. And,
Could go in there as well.
yeah, I think it would fit nicely there.
There should also be an info card with it.
Yep, we'll have to make one up. I'll take, I have some pretty good pictures of the integrated flight test.
I was thinking maybe as part of it we could include one of these stickers as well.
Yeah, for sure.
Look at the galaxies.
Yeah, one of these pretty cool. This is real Starship. Turn it off. I'm donating some movies. That's the thing I was talking about. But Joshua, isn't this a pretty cool man? I'll figure it out. I also got this bag we can put in. Like a temporary bag.
Yeah, it's a good spot to keep them safe until we can get them into the display case.
Yeah.
Mommy, what did you see the telly?
Yeah, all my stuff in. It fits in. So, I like contribute. Starship is I like talking to him too. And I like that sort of. I'm like a Starship expert. I know all about it.
Alright, thanks, Mark.
All right, I guess we are going to get started here. Welcome to McCarthy Observatory and our December 2nd Saturday Stars presentation. My name is Mark Polanski. I've been a volunteer here for somewhere around 10, 11, 12 years. The years kind of blur together at this point. Back in April, SpaceX had just completed Starship Integrated Flight Test 1. That was only 8 months ago. And in May, I gave a talk about the build-up to that flight test and some of the early findings. Just 3 weeks ago, SpaceX launched Integrated Flight Test 2 of Starship. And tonight, we're going to talk about how we got there and what happened. So first of all, what or who is SpaceX? SpaceX stands for Space Exploration Technologies. They are a private company operating out of Hawthorne, California, and they design, build, and fly the Falcon 9 and Falcon Heavy rockets, along with the Dragon 2 capsule, which carries both cargo and astronauts as crew. They have over 220 successful launches. Oh, wait a minute, that's a leftover slide from May. Over 280 successful launches. They've launched 58 times since May alone, including many flights to the International Space Station, including astronauts. They've successfully landed their first stage booster 252 times, with 173 in a row since February of 2021. They've reused boosters more than they've flown new boosters at this point. Some single boosters have flown as many as 18 times. They are on track in 2023 to launch over 100 flights in 1 year. So far this year, they are responsible for over 80% of the entire world's upmass into space. That other 20% is every other company and every other country combined. And 10% of that is China, an entire country. They're launching more than entire countries. That's to say that SpaceX understands reliable spaceflight. They know what they're doing. What they're doing with Starship is unprecedented. They're actually pushing the boundaries of known physics and material science. What is Starship? Simply, it's a ginormous rocket, the largest and most powerful ever made. It's very much an experimental and in-development vehicle. It's not operational or flying payloads just yet. And again, they're pushing the boundaries of physics. SpaceX had to invent new metal alloys for the Raptor combustion chambers. The engines that power this thing are so powerful they had to invent new materials to make it work. It's a super heavy class liquid-fueled orbital rocket system designed for full and rapid reuse for the entire vehicle, both the booster and the upper stage. Starship was selected by NASA as the primary lunar human landing system. This means it'll be used to land humans on the moon for the first time since the Apollo missions as part of the Artemis program. SpaceX has even more ambitious goals for this system. They're designing it to make life multiplanetary with the eventual goal of landing humans on Mars. Starship and the booster sit at almost 30 feet or 9 meters in diameter and almost 400 feet tall, which is 40 feet longer than an American football field. This thing's enormous. The booster stage is powered by 33 of those Raptor engines, producing 16.7 million pounds of thrust altogether. For comparison, the Saturn V rocket that took us to the moon in the 60s had 7.6 million pounds of thrust. Starship itself is technically just the upper stage. It's just the top half of the rocket. It has 6 Raptor engines for 3.3 million pounds of thrust after it separates from the booster stage. The total payload capacity is expected to be around 100 to 150 tons to low Earth orbit. there's going to be several different flavors of Starship for different use cases. There's going to be a propellant depot to help keep propellant on orbit, ready for transferring, so we can get further out into the solar system. The lunar lander will be part of the human landing system. They're going to obviously launch satellites with it. And some of these things are big enough to actually be a space station on its own. So they can just launch this thing to be a space hotel or fun things like that. The propellants are methane and liquid oxygen, which is different from the Falcon 9 for a pretty good reason that we'll see in a second. Big question. Why does it matter? Why is this important? It's just another big rocket, right? Obviously, it has a pretty high payload capacity. But what does rapidly reusable mean? With the Falcon 9, the upper stage is expended after the payload deployment. After it flies into space, it detaches the satellite, and then the upper stage will either fly back into the Earth and burn up in the atmosphere, or it'll end up transferring itself to a graveyard orbit somewhere out of the way. The point is the second stage can't be used again. It's used once, and then it's gone. The first stage of the Falcon 9 can be reused because it can land itself, but only after a period of refurbishment. It takes time to take the rocket, clean out the engines. It uses kerosene, or a refined kerosene called RP1 for its propellant, along with liquid oxygen, and it's a heavily carbon-based fuel. It's like almost like gasoline. It leaves a carbon residue inside the engine that needs to be cleaned out before it can be flown again. So far, the fastest turnaround time for a Falcon 9 booster has been about 3 weeks. So after it landed, it takes 3 weeks for them to clean it up and get it ready to fly again. Starship uses methane, which leaves no carbon buildup. So the idea is that it can fly, land, refuel, and fly again in the same day. That's at least the aspirational goal for it. It's also much, much larger. The largest space telescope we have right now is the James Webb Space Telescope. And it had to fold up like an origami figure to fit within the Ariane 5 launcher's 4.5-meter payload fairing. So imagine how big of a telescope we can fit in a 9-meter payload fairing. That's twice the size. So here's a list of how much it costs to launch 1 kilogram of mass, or about half a pound, to low Earth orbit on various rockets. Obviously, the space shuttle is the most expensive. Falcon 9 comes in, starting, if you throw the rocket away and don't reuse it, at about $4,100 per kilogram. If you can reuse it, it cuts the price almost in half. So where do you think Starship is going to land on here? How much do you think it's going to cost? $10 per kilogram. $10. We can see that the reuse of the Falcon 9 booster alone cuts the cost almost in half for flying to space. It's even less if the rocket can fly itself back to the launch site. We call it a return to launch site mission, because it doesn't have to land on a barge in the middle of the ocean. There's no extra cost involved. When a rocket becomes fully and rapidly reusable, the only real cost to fly it is the propellant, just the fuel. And of course the launch team to actually prep and operate it. SpaceX is targeting a nominal cost of $1 to $2.5 million per launch. So if you divide that up by 150 tons, that's where you get close to that $10 figure. But even at 10 times the cost, if that's even wildly ambitious, that's no comparison to any other launcher, either in existence or currently on paper being designed. When this becomes operational, it won't just shake up the launch industry, it's going to redefine it. And that's why this is a big deal and why it matters. To an extent, Falcon 9 and Falcon Heavy have already done this. You can see the price difference between a Falcon 9 and some of the other launchers in that class. And again, that's only with the first stage reuse. The classic thought exercise is to imagine how much air travel would cost if planes were single use. If you get on a plane, you fly to your destination, and then after you land, throw out the entire plane. How much would it cost to fly anywhere? That's basically what spaceflight has been up until this point. Until SpaceX came along and proved that reusability can be viable and economically sound. So where did Starship start? The first ideas started to appear around 2015 or 2016 with the initial development of the Raptor engine. From the beginning, SpaceX wanted to design this to be rapidly reusable, but also to use a rapid iteration and fail-fast approach to the design and build. What that means is they want to design something, build it, test it, break it, learn from what broke, redesign it, build it, test it, break it, learn, etc. Just keep going on like that. Quickly. Every design cycle incorporates lessons learned from what broke in the previous version. The original design for Starship called for carbon fiber, but early on they figured out that working with stainless steel was significantly cheaper and easier to work with, so they switched the entire design to stainless steel. Starting in 2018, we started to see this little tin can start to come together down in South Texas. This ended up being what was called the Starhopper, and it proved the concepts that you can build a spacecraft out of stainless steel, basically in an open field in the middle of the desert, and actually fly it. It took just 9 months from the first signs of construction to when this thing actually flew to 150 meters and came down softly. While Starhopper was being tested and built, the rest of the Starship family began, starting with Mark 1 and 2. Mark 1 ended up failing during pressure testing. They build these things like soda cans, where they're a very flimsy-ish material until they pump it full of pressure, and then the pressure ends up holding it together structurally like a soda can. Like if you take a full soda can, you can stack maybe 20, 30 pounds on top of it, and it's perfectly happy. You open up that soda can, pour out the soda, it's no longer pressurized. You put that same 20 or 30 pounds on it, it crushes it. So that's the basis for how these things operate. When they were testing the pressurization of Mark 1, it ended up popping. It failed under pressure because they were just figuring out how to make these things. Mark 2 was of the same design, so they knew it would fail in exactly the same way, so they ended up scrapping it for a totally redesigned Mark 3. Mark 3 then ended up renaming to SN1. They started the SN scheme of naming, and it also ended up failing during the cryo-proof testing. They pressurized it, and it popped, but in a different spot. So they had solved the problem from Mark 1, but now had a different problem popping in a different spot. So eventually they said, the heck with this, we're tired of building these full-size models just to get them destroyed. And they built a smaller quarter-size test tank called SN2. And they used that test tank to validate the techniques and the construction methods to make sure that they can actually pressurize it and have it maintain structure. And it worked. From SN2, they moved on to SN3, which successfully passed the cryo testing. They pressurized it and it didn't blow up. But it ended up crushing itself for a different reason. Remember the soda can analogy? There's basically 2 soda cans stacked up inside one of these things. And they ended up draining and depressurizing the bottom one while the top one was still full. So the weight of the top one just crushed down over the second one. So that was a big oops, but they learned their lesson and came back with SN4. SN4 was the exact same design. They learned from their mistakes. They didn't crush it. It did pass cryo testing. It had engines installed, and it actually fired its engines for a couple of times. But it ended up blowing up because of a loose methane hose somewhere on the ground surface equipment. Another lesson learned. From SN3 and 4. I'm sorry, there's a question?
He asked if there was somebody inside you.
Oh, no. Fortunately, there's nobody inside these because they know they're going to end up getting blown up at some point, so they don't put any people on them until they're sure they're safe.
It's like a silo, doesn't it?
It does, yeah. Yeah, the ongoing joke for these things when they launched them was that either water towers or grain silos could fly. It's a really eerie sight to see these things because you're in the middle of South Texas in the middle of a field and you see this thing just kind of take off and float by. It's really interesting. So this is SN5 and SN6. They both learned from the lessons all the way up to this point and successfully flew. They repeated the hopper test to 150 meters, came down and landed softly. SN6 was even smoother. SN5 took a couple of weeks to actually launch. SN6 only took a week or 2. So again, rapidly learning, rapidly figuring stuff out. So the problem is these SN5 and 6 only used a single engine. And to get further, they had to increase the number of engines. They needed to use 3 for the next set of tests they wanted to do. And the pressure inside SN5 and 6 wouldn't support being able to drive 3 engines. So they ended up coming up with another test tank, SN7, to validate new metal alloys. They are inventing new metal alloys to make this stuff work. And that ended up working. So SN7 laid the groundwork for SNs 8, 9, 10, and 11, which were all exactly the same. They all flew the exact same profile. This model here is actually of SN8. So it has all the internal tank structures and everything. I can take this apart afterwards and show you how it all works inside. But this was the first full-scale Starship model to fly and test out its really unorthodox method of reentry. You'll notice it has flaps on the side. Traditionally, with a space capsule coming back from orbit, it relies on a ballistic trajectory. The capsule is designed in a teardrop shape that is naturally stable. So when it enters the atmosphere, just the pressure alone keeps it in a stable configuration. It doesn't need to steer. It doesn't need to control its where it goes. That's what a ballistic trajectory is. Starship, though, when it re-enters, is more like a skydiver. It's going to belly flop, like you see in that image on the right. It's just going to fall straight down, using these flaps to control its attitude and kind of help guide it in the direction it wants to go in. A couple thousand meters before it hits the ground, it's going to reignite its engines in the bottom, flip itself vertically, and then propulsively land under engine power. So SN8 successfully took off. It made it to 15 or 12 kilometers, demonstrated the belly flop, the skydive, and all that went really, really well. It tried its best to land, but there were some issues with the tank pressure that prevented the engines from producing enough thrust, so it ended up crashing down hard on the launch pad, but it was vertical, ending in another glorious fireball. SNs 9, 10, and 11 were all exactly the same design. They repeated the exact same tests, but all 4 of them failed to land, but for different reasons. Every time they failed, they would learn something, fix it, and it's basically how many ways not to succeed. Then we get to SN15. So the jump is because SNs 12, 13, and 14 were all of the same design as 8. And after 4 flights, SpaceX figured they learned everything they could. They didn't have anything else they could do with that particular design. So all the lessons they learned, all the things they figured out that were wrong, were fixed in SN15. The other big thing was SN15 used a newer batch of Raptor engines that were proven to be a little bit more reliable. So on May 5th, SN15 took off. I forgot what year that was. I want to say that was 2021 maybe. SN15 repeated the same flight profile, but this time it landed successfully, proving that this method of flying and landing could actually work. So they learned enough from 15 where they didn't feel like they needed to fly that same profile again. So 16, 17, 18, and 19 were all backups for 15. But since 15 worked on the first try, they ended up scrapping all those and skipping right to SN20. So again, built on the lessons learned from the previous flights, SN20 incorporated a whole bunch of changes and a whole bunch of lessons learned. SN20 was actually built to go to space. It has a full heat shield, it has all 6 Raptors it needs to get to space, and it went through a full static fire campaign. It went through a full set of testing. All it needed was a booster to get it up into the atmosphere to fly off into space. So while the Starship testing was happening, they were figuring out how to build boosters too. They used the exact same construction techniques and learned a lot from building the Starships and testing them to produce these boosters. Booster 1 was just a Pathfinder. They just built it to see if they could build a booster. Ended up scrapping it right away. Booster 2 was a series of test tanks just to make sure they could actually apply the right amount of thrust through the engines to make sure it doesn't collapse on itself. Booster 3 was a full-size prototype that made sure the plumbing and all the manifolds and everything inside to get the fuel to the engines worked. And then B4, they dropped the N for some reason. It just became known as Booster 4, was the first booster that was intended to fly. So it was to be paired up with S20 to actually try to go to orbit. So in the end, Booster 4 and Ship 20 did not make the first flight. Based on the information they had, SpaceX thought the probability of damaging the launch mount was too high. So their ultimate goal was to just get past the launch tower. They wanted it to take off and not blow up and take out the whole launch pad with it. They didn't think Booster 20 or Booster 4 or Ship 20 were up to the task. So throughout all the flight testing they've done, they learned a lot about the Raptor engine. And they figured out ways to make it more powerful, more reliable, easier to manufacture, easier to test. And they came up with a new version of Raptor called Raptor 2. This made it way easier for them to make, test, and validate the engines, which is important if you need to put 30 of them on a booster. New test stands were built to push the engines to destruction. They kept blowing them up almost weekly to see where they were failing. And that data fed directly back into the construction of new Raptors. When one blew up, they learned why, tried to fix it in the next one, blew that up, and so on. With the more slim Raptor 2 engines, they could now use 33 engines on the booster, up from the 30 on the original design. So they built Booster 6 as another test tank to make sure that 33 engines could fit and that their fabrication was up to the task. And it ended up working. Booster 7 and Ship 24 became the first pair to use all Raptor 2 engines. After a long test campaign, on April 20th of this year, the first integrated flight test occurred. This was the culmination of all the testing and learning up to this point. Given this was the first scale test flight of the world's most powerful rocket, the primary goal was, again, just to clear the tower, just get away from the launch site and not blow up. Any flight data beyond that was just a bonus. And it did clear the tower, in more ways than one. In the end, it blew up over the Gulf of Mexico, after making it to about 39 kilometers in altitude, which was higher than any Starship prototype had been to this point. As an integrated flight test, it was enormously successful. It was the first time 33 relatively early model Raptor 2 engines roared to life together and propelled the largest, heaviest rocket ever made beyond the launch tower. It ended in the same spirit as the previous prototypes, with a wealth of data collected and lessons learned. And to be fair, SpaceX was actually aware of most of the failure points of this combination of booster and ship already. Most of them had already been fixed in Booster 9 and Ship 25, well before the flight test. So why fly, knowing the risks? Their choice was pretty simple. Fly it and collect real-world data that no simulation could provide, or let the booster and ship collect dust in the rocket garden like so many others before it. At some point, they just had to send it and see what happened. So this was the pair they decided were going to do that. So what actually happened with Flight Test 1? The thrust from 31 engines, because only 31 ended up lighting out of the 33, basically destroyed the concrete below the pad. There was so much force and so much pressure from the engines that it shattered the concrete and dug a hole, leaving a large crater below the launch mount. 2 of the Raptors ended up failing before liftoff, but the flight computer was set up to allow liftoff with at least 31 good engines. And this is the reason they fly with so many engines. If they lose 1 or 2, it's not a big deal. It can still achieve its goal. But on the way uphill, some back pressure from the exhaust plumes led to fires in the engine bay, which burned through several avionics cables, hoses, and ended up shutting down additional engines. Eventually, there are 2 hydraulic power units that end up actuating the engines to steer the ship, ended up failing, likely because of the fires in the engine bay. So without the ability to steer, the rocket lost control, and the flight termination system was activated. But it turns out that stainless steel at a high altitude, under really cold cryogenic conditions, is ridiculously strong. Not only did the rocket stay together through some dramatic tumbling and spinning, but the flight termination system had a hard time blowing it up. So the flight termination system ended up winning after about a minute, and the flight test did end up ending, sending pieces scattered into the Gulf of Mexico, which we have some pieces of, thanks to John here. He brought in some pieces of the thermal protection tiles that were on Ship 24. So we actually have a real piece of that here now, which is neat. Whenever anything doesn't go perfectly to plan with rockets, spaceflight, or even airplanes, a mishap investigation with the FAA is usually launched. A common misconception is that the FAA performs the investigation, but they don't. Typically, the investigation is handled by the company itself or an independent group of people commissioned by the company to look into what happened. The FAA simply provides oversight and makes sure the investigation covers all of its bases, and they provide the final sign-off. But they don't actually run the investigation. The findings for Integrated Flight Test 1 came up with 63 corrective items to help improve reliability, many of which were already incorporated into Booster 9 and Ship 25. So SpaceX rebuilt and reinforced the launch mount, but this time added a very large water-cooled steel plate. It's like a giant upside-down shower head to provide pressure. It's pressurized water to help dissipate a lot of the sound and pressure coming out from those powerful Raptor engines. A lot of the other corrective actions were around the robustness and redundancy of the systems on the ship, like redundant cables, redundant avionics, redundant hoses, to make sure that if something happens to one of them, it can still operate. The other big thing was better fire suppression. The booster on board has tanks of carbon dioxide that it uses to flood the voids and areas between the engines of the rockets to prevent fire from breaking out. So they increased the capacity of that fire system by 15 times. And we can actually kind of see that during the launch. This is Booster 9, just after clearing the tower during Flight Test 2. The bluish exhaust is the result of the methane and oxygen combustion. It's a very, very beautiful kind of deep purple color. The orange-looking gas above on the booster itself is a combination of gaseous oxygen and nitrogen being vented from the booster above, lit up by the orange glow of the sunrise, since this was at 7 a.m. Central Time in Texas. The gray gas seen spiking down between the engines is actually the carbon dioxide flooding the engine compartment, preventing fires from starting. So it's neat that we can actually see one of those fixes. So again, Booster 9 and Ship 25 incorporated hundreds of improvements and lessons learned from the previous flight, with the biggest change being the move to electronic thrust vector control. This is the system that steers the engines of the rocket to be able to point it in any direction. It's called gimbaling. Booster 7 used hydraulics for that, and because those hydraulic units failed, it could no longer steer itself. With the electronic thrust vector control, if one cable gets broken or something happens, it doesn't affect all the other engines. They're all independently actuated. This pair also introduced the idea of hot staging, which means that the second stage, or the ship, is going to light its engines before separating from the booster. Ultimately, that gives you about a 10% performance gain by minimizing gravity losses, which is kind of a big deal when you have a system this big. Integrated Flight Test 2 launched just about 3 weeks ago, on November 18th, 2023, around 7 a.m. Central Time. The perfect mission profile would have been to launch, clear the tower, perform that hot stage separation, have the booster turn around to fly back to a slow splashdown off the coast of Texas, with the ship continuing on to a near orbital velocity, so it could test the reentry and splashdown and end up coming down just north of Hawaii. The primary goal of the first flight test was just to clear the tower without blowing up. This time, the goal was to actually get to the stage separation. So they had loftier goals, higher expectations for this flight. And it worked. What went well? Most importantly, the water pressure cooled steel plate worked. The launch pad survived. There were no major issues that they found after the booster left. The booster itself did really, really well. It was a flawless countdown. It lifted off, and it flew perfectly. All 33 engines ignited, all 33 engines stayed on for the entire flight. Now, traditionally with spaceflight, you hear the term MECO, which normally means main engine cutoff. For this flight, it stood for most engine cutoff, because during staging, where MECO would normally occur, 3 booster engines remained lit to keep the stack under thrust, and there's 2 reasons for this. One is to keep the propellant, or the fuel, at the bottom of the vehicles, because as long as there's forward acceleration, the liquids will stay in the back where the engines are. Like if you're sitting in your car and you accelerate, if you hit the gas pedal, you get pressed back into your seat. That's an acceleration force. The same concept keeps the fuel pushed back against the back of the rocket. The second reason for the hot staging is if all of your engines shut down, the rocket ends up coasting. And it'll coast at a fairly steady speed for a short time until gravity starts to pull it back down to Earth. And we call that gravity losses. It's the same idea as if you're in your car, you're accelerating, you're getting pushed back into your seat, and then once you reach your steady speed, if you're on the highway, say 55 miles an hour, and you let off the pedal and just maintain that 55, you don't feel that force pushing you back into your seat anymore. You're coasting, you're at a steady state. But if you step on the brake, you start to decelerate and you feel the force pulling you forward. So the same thing kind of happens here with the rocket. As it's accelerating, the fuel is pushed back into the back of the rocket where the engines are. If the engines suddenly stop, it will coast for a little bit. And then as gravity starts to tug back on it, it'll start to decelerate. And as it decelerates, all that fluid tends to slosh forward. I mean, the easiest way to think about it is if you take a bottle of water, when it's full, if you try to shake the bottle, the water doesn't really have anywhere to go. There may be a little bit of an air bubble in the top, but for the most part, the water stays where it is. If you empty or drink most of it and end up with just a little bit left in the bottom, now if you shake that bottle, that water goes everywhere. If you swing the water bottle in a circle like this, all the water is going to end up towards the outside of it, for a similar reason as what the acceleration does in a rocket. If you suddenly stop swinging it, all that fluid sloshes forward. So, not a good thing for a rocket, because if it doesn't get fuel, the engines get starved and they stop hard. It's violent. So, in any case, hot staging ended up working, for the ship at least. The ship was able to light its engines, it took off, and it continued on to space. What went wrong? Really, it was only the bonus objectives. Again, the primary purpose of the booster was to get the ship to a point where it could separate and do that hot staging event. The bonus objective for the booster was for it to flip around, light its engines again, and fly itself back home for a soft splashdown off the coast of Texas. basically just doing a giant U-turn in the sky. It flies up and away from the coast, drops off the ship, flips itself around, and then flies home. That's part of that rapid reusability. They want to be able to fly these boosters back home so they could land them, fill them up again, and launch them again. That didn't work. As part of that flip process, they reignited most of the engines, but several of them shut down early in that boost back phase. The booster ended up losing control because of that, and it exploded, most likely because of its flight termination system, which is a safety mechanism that blows the booster up if it's going off course. We don't have any flight data as the public yet, so we don't get any internal numbers as to what actually happened. So at this point, anything you might hear about theories or explanations are entirely speculation based on what we can see. So my thoughts and my speculation, and again, I don't have any internal data or inside information to back this up, but during that hot staging event, there were some very abrupt acceleration changes noticeable in the telemetry. Normally during engine cutoff, deceleration due to gravity losses is just a few kilometers per hour, which the telemetry showed. When the Starship lights its engines during the hot staging, the booster velocity drops almost 200 kilometers an hour very quickly. And then as the booster lights its engines for the boost back, the acceleration increases suddenly. This sudden swing in acceleration could have caused the fluids to slosh around hard enough to either damage the internal plumbing of the booster, or at least it could have caused the pumps to pull in some gaseous propellant instead of liquid, which would cause the engines to shut down and damage them. In the end, enough engines shut down where the booster couldn't complete the boost back, and once the flight computer saw that it wasn't going to make its objective, it activated the FTS and blew it up. Ship, meanwhile, after separation, did very, very well. All the engines lit, and it continued on its way to space. It went well over the established line of space called the Kármán line at 100 kilometers, reaching an altitude of around 149 kilometers. Everything seemed to be going perfectly for almost 4 minutes. Then suddenly a large plume appeared, like you see in the middle image there. Coinciding with that large plume, the liquid oxygen levels seemed to start dropping faster than the liquid methane. A second puff appears about 35 seconds later, although throughout all of this, the ship continued to accelerate according to the speed number that's shown on the screen. About a minute after the plume appeared, the engine shut down at about T plus 8 minutes and 5 seconds. The telemetry continued to update for a few seconds before a large cloud appears, after which the telemetry stops updating. So presumably at that point, the large cloud meant that it blew up because of the flight termination system. So my speculation again, I think either one of the engines blew up or a valve somehow failed, causing the apparent oxygen leak, starting at T plus 706. The ship continued on its way until what may have been a predefined second engine cutoff, or when the engines are supposed to stop. It could have been based on elapsed time. Maybe it was only supposed to fly for 8 minutes and 5 seconds. Or maybe it was based on how much propellant was left. If it saw that there was only a certain amount of methane and liquid oxygen left, it might have stopped it. But either way, when SECO occurs, it's only traveling at about 24,000 kilometers per hour, which is still pretty fast. But you have to get to 27,000 kilometers per hour to get to orbit. So a ship came about 3,000 kilometers per hour short. But at such a late phase in flight, it would have only taken another 20 or so seconds under power to reach that speed. So it's kind of crazy to think that just 20 seconds of thrust is the difference between splashing down in the Caribbean versus splashing down in Hawaii. 20 seconds, all to get all the way around the world. So after SECO occurs at 8:05, the flight computer knew that it was short on velocity. And at that point, it would have triggered the AFTS, knowing the flight termination system, knowing that it wasn't going to make its destination. So a couple days ago, SpaceX released a highlight reel of IFT2. So let's take a quick look at it.
Attention all operators, countdown 1. Go, flight 2 of Starship. Get attention to 7 a.m. Central. Route 1.
Go.
Route 2. Go. Stage 1. Go. Stage 2. Go. Copy, go for flight. Clock is rolling. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff.
in mind this thing is longer than a football field. All 33 engines lit up and working fine. There's Nico and the hot staging. There's the attempted re-entry, the attempted boost off burn. They're excited because they hit their primary goal of getting to stage separation. There's the engines failing and the flight termination system. The ship continuing on to space. All 6 engines working fine. Until boom. Flight 3 up next. So what comes next? Again, this is all part of a development cycle. This is not an operational vehicle yet. They're still testing and figuring out how to make this thing work. My last talk in May was called Success Through Failure, because you learn the most when things don't fully work as intended. As long as progress is made with each attempt, it's a success that comes as the direct result of learning from previous failures. So keep in mind this fail fast, rapid iteration approach. They learn, they build, they test, they break. Rinse and repeat. IFT2 was just another test. They broke it, they're going to learn from it, and they're going to build on the success from it, as they learned from the successes of in-flight test 1. And just as Booster 9 and Ship 25 were basically ready to go after IFT1, Booster 10 and either Ship 26 or 28, we're not sure which one yet is going to be the next to fly, but they're basically ready to go now. Data is still very much being reviewed and analyzed. And this time around, SpaceX is being a lot more tight-lipped about what actually happened during the flight. And we have a pretty good idea that's because they don't want to cause any public speculation or any public hounding of the FAA during the investigation. Because after IFT1, there was a lot of public backlash to why the license to get IFT2 launched was taking so long. So we think they're trying to keep that more private and close the loop on that to try to get that resolved quicker with the FAA. Again, a mishap report will likely need to be filed. There will likely be more corrective actions. But we expect that to be way, way, way fewer than after flight test 1. IFT3 could fly as soon as January. The booster is ready, the ship is ready. All they need to do is close out that mishap report and get back to the pad. They've also talked about Raptor 3. Again, now they've flown the Raptor 2s enough, they have a wealth of data on their performance and their weak points. So they're going to incorporate all those changes into the next generation of Raptor to make it even more powerful, more resilient, more robust, and easier and cheaper to make. Ship 2 has also been announced, Ship version 2. They're going to try to stretch it to make it a little bit longer to allow more room for propellant. They're likely going to increase the engine count to 9. They're going to try to have 6 vacuum-optimized Raptor engines along with the 3 sea-level Raptors, along with countless performance and reliability upgrades. So just to give you an idea, this is a chart courtesy of the Ring Watchers, a group that keeps track of all the happenings happening down in Starbase, Texas. Most of the stuff is built in tents out in the open. So people have set up cameras that are streaming 24 hours a day watching what's happening there. So we have a pretty good inside look as to where they are with their production. Booster 9 obviously flew. It's currently in the Gulf of Mexico. Booster 10, so this chart was produced the day after the flight test. As of today, Booster 10 has all of its engines, and it's waiting to roll out to start its static fire campaign. Booster 11 has been crowd tested. It's waiting for its engines now too. Booster 12 is waiting for its crowd testing. Booster 13 is in the process of being assembled, and we've seen the parts for Boosters 14 and 15. On the ship side, 25 is now currently in the Atlantic Ocean somewhere after flight test 2. 26 has gone through a static fire and crowd testing campaign, so there was a suspicion that it might be the next to fly, and it may be trying to do a propellant transfer demonstration, which is one of the requirements for the human landing system, meaning it needs to be able to get propellant from one ship to another in space. That's where the Starship Depot variety comes into play. Otherwise, it might be Ship 28. 28 has the full flaps and heat shield and everything it needs to do a full re-entry. whereas 26 doesn't have any of the recovery hardware. So 26, if it flies, would end up just burning up in the atmosphere, and it'd be expendable. So 28, 29, 30 are all mostly assembled. 31 mostly assembled. 32 they have pieces of. 33 they have pieces of. So they're literally building a factory to make these things. So if they blow it up while testing it, it's not a big deal because they have plenty to go. So yeah, expect the flight rate to increase over the next year. The more milestones they hit with this, the faster they can fly. If they can fly a complete flight profile, they don't need to file a mishap report, which means there'd be no delay getting a license for future launches. So we expect over the next year the flight rate to increase significantly, and the next flight could be as early as January. And every flight pushes us further and closer to that goal of becoming an operational, orbital class, fully reusable rocket. Any questions?
Yeah, Mark, thank you very much. Very comprehensive. You say it's 150 tons to lower orbit?
That's the expected upper limit of it, yeah.
Where does the payload go? How much of that is gas, fuel? How much where does the payload go?
The good thing about this model is I can take it apart. This is the payload volume. There's a tank header here and another tank header here. This is the methane tank up here. From here to here is the oxygen tank. Because if there's any chemists, when you take a reaction of methane and oxygen, it's usually 2 oxygen for every methane, the way it combines. So you need twice as much oxygen as you do methane. So this is the tank section. This is the payload section. So there's a lot you can do with this volume. Yeah.
So, which prototype do they think could be a first one with an operational payload door?
Ooh, that's a good question. I think they might be trying to save 26 for that because again, it doesn't have the recovery hardware. Because they can build these things so fast and so cheap. The recovery, at least for the first couple of flights, may end up being like a side goal, like a side quest. The other big thing they're trying to gun for, besides the HLS, is they need Starship to be able to launch their next generation of Starlink satellites. Right now, they've been launching on the Falcon 9, and they had to redesign their new version of the Starlink satellite to fit within the Falcon 9 payload. Their actual second-gen Starlink satellites are designed with Starship in mind. And their goal may be to try to reuse the booster because there's 33 engines in there, and the less of those they throw away, the better. But the upper stages with only 6 engines, they're not going to mind expending those at first. So the first flights that end up with payload are very likely not going to be recoverable. They're not going to have the fins or the heat shield or anything on it. The goal is just to get into space with a massive amount of volume, deploy stuff, and then have the ship burn up on its way back down.
I've also had a theory that Ship 26 could potentially be used as an HLS prototype. What do you think is the possibility?
It wouldn't be a full-scale HLS prototype. Somewhere on Starbase Texas now, I have seen there is a mock-up right now of this upper section for the human landing system for NASA. I know there are NASA reps that visit periodically, usually a couple times a month, as representatives of the human landing system, and they're working hand in hand with the SpaceX engineers to make sure that everything is what they need, what they want, and it's all on track to launch.
Because I have a theory that maybe in the future they'll modify it into a full-scale HLS prototype.
Yeah, they might. I mean, because they can build these things in sections, they could build out the HLS upper part, the upper part of the Starship, and then just made it to a tank section at any time. It's likely going to be a few years before we get there, because again, their goal is now just to make it an operational rocket, get it to orbit, make sure it's reliable enough to actually put payload into space, and then they can start focusing on the reuse and optimizing it. All right, I have one more big thing to announce here. As most of you know, the mission of the McCarthy Observatory is to further science literacy. We want to get people excited about science through astronomy. But our current equipment is aging, we have some compatibility issues, and it's starting to become unreliable. The telescope and mount are over 23 years old. Both have served us well for those 23 years, thanks to the care of the volunteer staff here. but it is starting to show signs of age. We can no longer get spare parts for things, and we have to get really creative when something breaks. Our cameras are also over 20 years old. They have really slow transfer speeds. They're relatively low resolution, and the software is aging out. I have to keep a computer running Windows XP just to make sure we can do stuff with it. So today we are announcing the campaign for the next 25 to bring the McCarthy Observatory into the 21st century. We're looking to raise about $75,000 to substantially upgrade all of our core equipment. We're looking for a modern mount, which will be way faster, way more accurate, better guiding performance, more reliable, easier to operate, and a larger optically superior telescope. Our 16-inch, again, has served us well over the years, but it was a mass-manufactured telescope in the early 2000s, and the optics are not, they're good, but not as good as we'd like for some things. We're also looking to get a new camera with better sensitivity and higher resolution to produce some better images and science. An incredibly generous anonymous donor has pledged to match the first $25,000 of donations received by March of 2024. That'll get us 2/3 of the way to where we want to be to get everything operational. The observatory was built and is run by an all-volunteer team funded entirely by donations and grants. So 100% of the proceeds go directly towards equipment and maintenance. There's no administrative fees, there's no overhead, there's no anything. Every dollar we get goes towards equipment and maintenance. Our current equipment has endured for almost a quarter of a century, providing breathtaking views. I'm sure many of you have looked through that at some point in the last couple of years. We've discovered 4 asteroids. We've helped confirm and refine the orbits of thousands of other near-Earth objects to make sure we're not going to get slammed with a piece of rock at some point soon. We've performed spectral analysis of stars, asteroids, comets, and of course we've taken many, many pictures of all the things that are up there to see. So our goal is to provide the community with an even better resource to provide all of the above for the next 25 years and beyond, plus the ability to support more ambitious projects the students have come to us with, more advanced scientific collaborations, and imaging with improved reliability and precision. So thank you very much. So I don't know if this guy is cleared up at all, but they might have the telescope open. I'm not sure. Otherwise, yeah, please join us next month. I think January 13th will be our next Second Saturday Stars.